and you will get a video on your YouTube channel. Like,
Okay.
oh, I also wrote Kitty into my calendar, and Google was smart enough to change it to a cat. I'm like, dude, no.
That happened to my boarding pass. So we were flying to France a few weeks ago with my parents, and my phone is in Spanish because I
Yeah.
like practicing like that. And when I
Oh,
open my boarding pass, my the word cat in Spanish is gato, and my name was didn't say on my boarding pass Kitty Kovac, but Gato Kovac. It somehow translated it to Spanish to cat, and I was looking at it like, what the hell?
no.
Yeah. We were laughing so hard when we saw it. Then I had to change my phone back to English so the people at the airport wouldn't be questioning if it's actually my boarding pass.
Yeah, to me, it was a culture shock. When I went to Hungary, I noticed that locals keep their phones in Hungarian and also their PCs. And I'm like, isn't English the default language for technology or
Yeah,
was it not?
exactly.
And yeah, I had a colleague, Steve. Steve kept all of his things in Italian because he wanted to learn Italian.
Hmm.
And he's quite good at Italian. I mean, I'm not always on the same page with the guy because he kind of follows even stupid rules to the book and doesn't allow kids to use their phones or whatever, even for educational purposes. Something I don't like, and also the fact that he was trying to be as servile as possible towards people who were not exactly looking at students' best interests. So yeah, but in this regard, indeed, a remarkable man. So yes, someone is not monofaceted. That is what I'm trying to say. Even if I had a bad experience with someone, doesn't mean they're a bad person. I caught them off guard at a bad moment, or they were afraid of things that. In my eyes, might seem irrational. In his eyes, might be really important. But yeah, professionally, I'm not sure, but in other cases, yeah, decent human being, I guess. But the bottom line is, I pretty much like to assess things from many perspectives and not make an emotional and hasty decision on
Hmm.
things because I may make a mistake and I may prohibit myself from opportunities that would otherwise have benefited me. Same thing has happened with my biochem teacher, who is an excellent man, and people started spreading rumors that he hates Hungarians. I'm still invited to any PhD defense that occurs under his supervision. He's a great guy, by the way. He's tough and he's strict, but he's a great guy. Yeah. Why is bonding so important? Well, bonding occurs because everything wants an energy minimum. Basically, the universe wants a chill pill. Obviously, we're going to talk a tad bit about Lewis structures, the octet rule, but the octet isn't always law, and we're going to talk about um, different states in which matter may exist. Why would it exist? Well, because it always tries to achieve that particular energy minimum. Does it always occur? Well, it depends. It depends. Yes, the number of protons always remain the same, but electrons may be transferred, and it depends how good are we at holding on to electrons. Well, the sodium chloride electrolyte obviously is well known to you in physiological solution. Phosphates are important for bone, for ATP, DNA, RNA. I think if I would just say phosphate, there would be several ramifications of what you would actually think about. By the way, if I would just coin the term phosphate, what would come to your mind? You would just have to talk about the term phosphate.
Phosphate. Um, I don't know. The phosphate, probably something with DNA.
Yeah, something with DNA, something with RNA, something with protein activation, phosphorylation, right?
Yes.
Crystals that form your bone and teeth, yeah?
Mm-hmm.
Calcium apatite crystals, hydroxyapatite, and phosphate. What else? Buffer systems, right? There's so many things in physiology that, or even cleaning supplies. Yeah.
Yeah.
Good, good. Now with carbonate, obviously, it's going to be a similar bicarbonate and also carboxylate. Okay, so carboxylate, why a resonance structure occurs. As you can see, we're we're viewing it from a different perspective, and obviously, in the case of chlorine as well, 7 valence electrons always. Yes, if it gains an octet, it has 8 electrons. So sodium loses, chlorine gains electrons. Why? Well, because one is less electronegative than the other.
Mhm.
One's nucleus isn't as good as holding on to electrons as is the other. In covalent bonding, they're going to share their electrons, and obviously those electrons are going to be shared, but not universally the same way. Yes, and once you have real-life molecules, you can predict their pharmacological activity spectrum. That sounded like a long, nasty word. What does pharmacological activity spectrum mean? Well, if I take an aspirin, it seems like a mundane drug, right?
Hmm.
Aspirin nowadays would probably not get approved for human consumption
Why?
because of the side effects. Teenagers, children probably wouldn't be allowed to have it at all. Why? Because it's a non-steroidal anti-inflammatory agent, and it hasn't proven to be perfectly safe for everybody. I mean, Bruce Lee died because of an aspirin. Oh my God, you don't know who Bruce Lee is. I keep forgetting that younger people don't really watch 70s action movies and stuff like that. He was a renowned martial artist and a film star and an absolute icon. And he was the pinnacle of fitness. He was the pinnacle of health back in the day. And he died of an allergic reaction uh,
Okay.
to medication. Yeah, it's just really strange. I'm really thinking about having an EpiPen prescribed, so I would have an EpiPen on me at all time in order to be able to save a life at least. Um, in the preschool where my son was going for a year, they had an EpiPen for each and every kid.
An
And
EpiPen
each,
for each and every kid?
yeah,
Why?
you can't know when someone has an allergic reaction to anything, and it will save their life.
And what if someone didn't have any allergies?
It's fine, then they'll throw it away.
Oh, okay.
Yeah, there's two kinds of people. My colleague who's an immunologist, uh, he's a very good immunologist. I'm not saying he's a good person at all times, but he's a very good immunologist, and I'm looking at the positive. He said, look, son, there's two kinds of people in this world. One had an allergic reaction, the other one's going to have one. I'm like, dude, that sounded dark. He said, I'm not being dark. I'm just telling you the truth as it is. And yeah, it's true. You never know. You never know. That's why. Just because I have no known allergies, it doesn't mean that I'm not going to grab a Snickers bar and die of an anaphylactic shock.
Hmm.
So obviously, the chances are low, but never zero.
Yeah.
Um, one of the Jewish Russian girls told me this that just because the chances of something are minuscule, it doesn't mean zero. So yeah, being attacked by a cow is far more likely than being attacked by a shark. I'm like, it's true, but it's very unlikely. Yes, but not zero. So yes, that's the thing. Later on, we're going to talk about molecular geometry, hybridization, orbital theory, acid-base theory, and stoichiometry as well. But for now, how do they share, transfer electrons, and what are valid Lewis structures? And obviously, you know the books. Stoker is the one we're focusing on. That's the base. But also Chang is very good, especially with its examples. Um, and all the others are recommended as well because when you compare them, you're going to see that they're talking about the same thing but in different details
Hmm.
and with different things being important. The Stoker book is a good foundation.
Hmm.
But yeah, it's like when you have a extra detail, you're trying to draw the statue of David, and first you start out with a stickman figurine, and then you dress it up, and ultimately it becomes the pinnacle idea of ancient Greek culture and philosophy. And by the
Mhm.
way, these statues used to be colored. The paint just faded. So yeah, they actually used to look human-like. Yeah, really interesting. Yes. In the case of carbon dioxide, as you can see, the Lewis structure is going to show an octet. This goes to everybody, and there's an excess of there's an excess of electrons, as you can see. So is the Lewis structure correct?
Which Louis structure? The
This one right here.
mm,
Not really too many electrons.
two main electrons, yes.
We have to be very careful about that. Phosphate, yeah, phosphate's all right. Carboxylate's all right. Nitrate, yeah, more or less, it's a resonance structure, so that extra bond is just flying around through all the others. Yes.
Is it okay to write three dots next to each other? Three of the
No, three dots is always too much. Yes.
It's too much. Okay.
It's always because they form these duets. They
Okay,
form
yeah, yeah.
these
Okay.
duets, and when there's a third one, you can be suspicious. Sometimes it may be a typo, sometimes it may be generated, sometimes it may be something extra.
Yes.
But
Hmm.
it does take quite a lot of convincing, especially with language models, to actually generate the right one. Sometimes they're
Yeah.
good at it, sometimes they're not that great. But if you would want to draw them by hand, it will never turn out that great.
Okay.
In this case, it did do quite an efficient effort, and yes, you recognize the structures. In this
Hmm.
case as well, chlorine has an octet, perfect, it's all right. Hydrogen too shares the electrons instead of transferring them. Uh, why? Why can't the hydrogen take the other hydrogen's electron, as does chlorine in the case of sodium?
Mm, it doesn't have the capacity for it.
Exactly, it doesn't have the electronegativity to do it. I mean, if you have two guys who are of the same strength, of the same build, it's far unlikely for either one of them to win in an arm wrestling tournament against one another, right?
Mhm.
Again, two valence electrons are necessary for an octet, but in this case it's oxygen 2 minus that already has an octet. Nitrate cannot be shown as a fixed double bond because the extra electron forms a resonance structure and belongs to all three oxygens the same way. That is the whole thing about a resonance structure. Now, in the case of covalent bond formation, in the case of hydrogen too, what we're going to see is that as they share their electrons, yeah, their energy becomes lower, and that lower potential energy contributes greatly to stability. So a covalent bond forms under Earth conditions between two hydrogens because in under the circumstances that enables a lower energy. Same is true with ionic attraction. Obviously, since cations and anions are formed, as they attract one another, they form a compound. Can I call an ionic compound a molecule?
No.
Not at all, because molecules require what? They require only covalent bonding. Yes?
Yes.
So whenever we hear in TV shows, back in the day, because we used to watch TV because our grandparents really loved TV. We like TV too. We were told that we are going to turn out really stupid because of watching TV. Well, guess what? I don't think we did. Same thing is with screen time with small children. They're gonna be autistic because they spend too much time on their computer, on their phone, or whatever. Look, autism and ADHD, they're a spectrum, first and foremost. Second, their diagnosis has become much more broad. So more people fit the description. To me, it's a bit suspicious because it's not like a blood test. Like you're AB positive. That's your blood type. Without a doubt, anywhere, if they measure the same thing, we're going to get the same results. With such things, I'm a tad bit suspicious that it's just psychologists trying to underline their importance a little bit more because even in the pharmaceutical industry, I know of people who are trying to help people with these conditions, and they're trying to create new drugs that enables them to function better in society. However, the person who actually came up with these terms, she said just recently that, oh, everyone can fit the description. I mean, that's great. That's really scientific. Because I have had a lot of students who got labeled with these, and obviously the school would get more state funding because of the diagnosis. The kids did need more work. Many kids need more work. I needed more work. Everyone needs more work because we don't have the same characteristics as people. That's okay. That's fine. Let's say I might need more help with basketball, others might need more help in mathematics, others with languages and reading. But it
Mhm.
doesn't mean they're sick. Yeah, because I really don't like it when they label kids who need care sick because they're not. They're not. Every child needs extra work from the parents and from the adults around them in order to be able to do better. And we have had children like this after the first year of school, in the second year of school, in the second grade. I started teaching, and so did many other people who were better at reading and math. They started teaching kids who were not that good at it. And by the way, that is the most effective way of teaching when you learn from a friend or someone who is trying to culturally be more involved with you. Yes. And this is something we forget over time, and then we label the less fortunate children the gypsies or poor people or whatever, and then we come up with politically correct lists that we can tick and feel good about ourselves and not actually help them. The most help we can give is by honestly going there and asking them, "What's wrong? Where did I lose you?" I mean, I remember Ferike, he said, "Eh, damn," he was surprised that he actually understood. So yes, I think you do have people like this in your class, despite the fact that it's a good class, right?
Yes.
Perfectly normal, perfectly normal. Back in the day, we used to have a mentoring system. In our case, it grew on its own. In other cases, it did not. But we didn't label anyone bad because they were not that good at something. We pretty much tried to help as much as we can. In the case of nitrogen, obviously, it's just 5 valence electrons. And in the case of oxygen, it's going to be 6 valence electrons, 7 in the case of fluorine,
Chlorine.
whenever they would strive for octet. And who has an octet? Neon has an octet. However, helium, helium's not even on the periodic table for some reason. Helium has a duet. A duet is also a stable electron configuration in the case of helium,
Helium. Yes.
because it allows an energy minimum, right?
Yes.
Now, oftentimes language models fail to understand these, and you can try teaching them as much as you can. They're going to come up with lovely graphics, but it's really difficult to convince them otherwise. But we know better than that. Basically, uh, these were called main groups and these were called side groups back in the day. Nowadays, everyone has their own number. And Lewis structures, they begin with valence electrons. Why do we have Lewis structures, by the way? Why do we have Lewis structures? There was a guy in the United States, Lewis, and he found this to be a perfectly valid explanation to what we see in nature. That's why it's called a Lewis structure.
Mm-hmm.
Nobody actually told me that, and I started asking these questions that you asked. I remember you asked me about Z. I've been studying chemistry
Yes.
for 2 decades, and I never questioned it.
Did you find the answer?
Yeah, yeah, Zal. It means number. Zal, number.
Oh, okay.
Kilo number. Yeah, yeah. In Hungarian, sorszám. That's what it means. Zal. I knew it was from German, but I don't know enough German to be able to.
Uh-huh.
I mean, what I know from German, I'm really sad to say how I know a bit of German. I mean, for us, it was always mandatory to read a couple of books. One is the 40 Days of Musa Dagh. It's about genocide against the Armenians. The other one was I Was a Doctor in Auschwitz, written by Miklos. He grew up in the same city as I did. And yeah, he was a thorn in the backside of communist Romania as well. In 2014, there was a Romanian researcher who commented on him. He said he should have died in Auschwitz because he should have been brave and die because he shouldn't have done all those autopsies he did. He was part of a Sonderkommando and was held at gunpoint 24/7. And then you have someone who has a PhD in history from Romania who dares to actually say anything against someone who actually survived the Holocaust. Uh, yeah, it's despicable. It's despicable to say the least. I mean, there has been genocide ongoing in Romania against Hungarians. Nobody speaks out against it. If they do, it's with a political reason, and it's a silent genocide. And there are still human experiments going on the misfortunate in many hospitals in secret. And when these things pop out, usually the doctors who are whistleblowers, they leave the country. I know quite a few people from my generation who did that and who were brave. Quite a few of them are friends of mine. They're either pediatricians or gynecologists, and people just don't really realize how dark things may occur in this world and what we can do against it. And a lot of people stand up against it. They just don't make the news because doing the right thing isn't exciting enough. So yeah, I try to avoid this kind of things and talk to people. When something happens, I talk to the person experiencing it firsthand, and they know what's best. Yeah, because they know. They know. So yeah, don't listen to gossip because it's a vibe, it's a feeling, it's not fact. They told me that this or that river is polluted. Okay, I took samples, analyzed them myself. It turns out they were not wrong. They are polluted, but they're below the threshold that government agencies are able to measure. Is it bad for you? You're not going to die because of this. So reality is boring. Reality
Mhm.
is nuanced. Yes. Reality doesn't provide munitions to hurt somebody else. It provides answers to which you can find better solutions to do things in a more effective way. The duet rule and the octet rule, they go hand in hand. Yes. Some can only get a duet. Some are going to strive for an octet. Some can't get either, but they will strive towards an energy minimum. The chill pill. Yep. Ions achieve stability by getting a noble gas electron configuration. Hydrogen is a special little bloke in that regard. It can be hydrogen plus, hydrogen minus. It depends on the environment. And why do we have a heart right there? What does sodium and chlorine have to do with blood pressure?
Sodium and chlorine.
Think about salt. What happens when somebody who is not you, because obviously you're healthy, but somebody who let's say has a predisposition to high blood pressure and doesn't really metabolize sodium that well. Let's say they're from the north of China, they're from Hubei province or Wuhan, or let's say they're from East Hungary, probably of Yas origins. Their people come from the north of Iran, and they have a genetic predisposition to not metabolizing sodium the same way as everyone else does. They can hold on to sodium, and the surge they can hold on to.
Well, then they probably will raise their blood pressure. No?
It will raise their blood pressure exactly because salt draws water. Perfect. Dude, I could probably give you a passing grade in physiology just by using your logic. Yeah. Yeah, okay. We're definitely making progress. Yes, indeed. We actually did an experiment like this in physiology class. I mean, it's usually a morning class, and a lot of kids don't eat anything for breakfast. It's fine. Far be it from me to judge anyone's diet. I mean, Dr. Fattah is giving out free medical advice. Thank you. But the bottom line is, the kids who didn't have any breakfast, their blood pressure and heart rate did rise a little bit because they had to participate in class, and we took their blood pressure and heart rate. Then we fed them 30 grams of crisps, and then we took their blood pressure and heart rate again. Everyone got the same dose. Yep. And in
Mhm.
about 10 minutes, we took their blood pressure and heart rate. And oddly enough, the girls, who were not particularly big, obviously, imagine an average girl, yeah,
Okay.
or more on the smaller side. Let's say 55 kilos, 1 meter 60, 1 meter 65 height. Maybe. I'm not sure. I mean, nurses, midwives, they're not usually heavy set. Some are, but there's no problem with that. But they were the ones who volunteered for these experiments. And we also had physiotherapist boys who were these big muscle men. Yeah. And a few of them did have a predisposition to high blood pressure. He was taking blood pressure medication as well. And the same dose of sodium chloride brought about completely different reactions from all their bodies. Yeah? The tendency with the smaller girls was that their blood pressure and heart rate became lower and more regulated. Why? Because for them, this was a comfort meal and they skipped breakfast. With the boys, obviously they're well hydrated, first of all. Second of all, they probably had creatine, protein, and who knows how many things with this. And one of them, as I said, also had a predisposition to high blood pressure. Mr. High blood pressure guy, his heart rate has risen by 7 beats per minute, which is, let's face it, quite significant. It's like becoming more excited, and his
Mhm.
blood pressure became a tad bit higher as well. And let's face it, the young man was around 80 kilograms, full of muscle, no fat at all. I mean, an absolute unit of a man. He has my respect. He keeps himself on the Spartan conditions, but he makes sure he doesn't overindulge in sodium for that reason. Now, should I tell everyone to reduce their sodium intake? No, just muscle man with the sodium and with the blood pressure issue. He should mind his sodium. The girls, they can eat an entire bag of crisps. It's okay. Just don't make it a habit. Why? What's going to happen? They're going to drink water and release it the usual way. Mr. Muscleman, he might have an edema, he might have higher blood pressure and heart rate, so we do not want him to progress in that direction. Yeah.
Yeah.
So that's why we had the heart right there. By the way, he's doing well. He's managing his blood pressure rather well, and he's perfectly healthy. Great guy in every way. And he's a role model to younger kids. He helps teenagers in bodybuilding, and he's perfectly natural. Whatever he achieved it the natural way. He's been lifting weights since the age of 14, and now he's 22. Yeah. I
That's nice.
mean, yeah, I have a lot of respect for these men. Don't get me wrong. I'm not saying that they're stupid or anything. A lot of people assume, oh, they're probably dumb and whatever, and they're on steroids. They are not. They are not. No, no, no. It's the exact opposite in this day and age. Yes. Oopsie, made a huge jump. Um, it's a useful model, yeah, the octet rule, but it's not always a universal law. Sometimes you may have odds electron species, or sometimes you may have expanded valence shells. Most second period atoms obey the octet. Hydrogen obeys the octet, but it's a guide, and we have to check electron count, formal charge, and known exceptions, because sometimes 12 electrons is okay, sometimes 10 electrons is okay. Why? Well, let's say I can't drive an Aston Martin, so I'm going to go with a Ferrari. Poor me. Yeah. That's really odd coming from a guy who basically takes a cab everywhere or whatever. Now, in the case of bionic
On
bones,
I'm sorry, on the previous slide, the BF3, why is there seven electrons around one of the Fs? Where is that?
oh no, that's
It's incorrect, right?
That's incorrect, yes. And in this case as well, you shouldn't have a double bond. Yeah. These
You should or
bonds,
shouldn't.
you should have a double bond,
Okay.
and you shouldn't have all those extra electrons. And this should be kind of like a coordinate covalent bond. Yes. There are some weird exceptions, and unfortunately, sometimes these models just fail to understand all the dots. But yes, you know better. You know
Okay.
better, and that is what matters. And of course, even in this case, I mean, you lose an electron, yeah, and that will get you an octet. But 6 electrons outside and 2 electrons in the inner on the inner side, right? Or 2 electrons outside, 8 electrons. It depends on the structure. And in the case of chlorine, on the outermost shells, you have 8. So 8 and 8 as well, but one lost an electron, the other one gained an electron. And gaining that electron allowed it to increase its diameter, while the cation has a smaller diameter than the parent atom. And we're going to talk about that as well. Metals always lose an electron. Non-metals are more likely to gain electrons. It depends who they're up against. Yes. And in the case of ionic bonds, there's always electron transfer. And in the case of covalent bonds, there's electron sharing. Why? Because they can't take it away from the other one. Yeah. When I was your age, we still learned about electropositive elements. Imagine that.
Mhm.
There's no such thing. There's no such thing. I mean, is it easy to take candy from a baby? Yes. Is it because the baby doesn't want it? No. You just can't hold on to it. Yeah. By the way, I trust the government of Hungary, Romania, and governments in general, so I have solar panels and power banks on me. And my wife was laughing. I mean, she said that's the most powerful political statement. I mean, I don't care which government is in power. As soon as we start getting promises about having proper power, I'm like, okay, this is something we're not going to have. So let's do something about it. Let's have a backup. I wish human stupidity would be able to produce power. We would be able to reach the stars. Yeah, but no, it's never a bad idea to have a solar panel power bank just to be able to remain connected in the um, mobile phones and whatnot. And yeah, for homes, I don't know for homes what's the best idea, but yeah, I think the region needs to cooperate better and needs to do better in many regards. Is everything okay power-wise at home?
Yes.
Thank God for that. Yeah. We were actually joking about this that Romania only has a president and Hungary only has a government. And Romania is doing better because it doesn't have a government. It already happened a few times that for 6 months it didn't have a government. And people were the happiest then. And everything worked because nobody told people who are running the country how to run the country. They did their best and it worked. So I don't know. Maybe someone should publish a paper on this.
Mhm.
I wonder what it would look like. I really much want to research this, not to poke fun at politicians in general, because I don't know much about the inner workings of this, but I can imagine quite a few things. But as a living, breathing organism, why is this? Why is this? Because older people make very good observations. They're not that well educated in university surroundings, so they allow themselves to observe things that others would deny existing. It's like with a small child. Why is that person's leg missing? Why is that person so fat? Uh, these are good and valid questions, and they're not hurtful. Yeah. One of the kid asked, "Why am I wearing glasses?" And I responded, and the mother was so ashamed. And I'm like, "No, that's such a good question." It wasn't like four eyes, you're despicable. No, he was asking a valid question.
Hmm.
Yeah, you should answer these questions because kids are great. Kids are great. Yeah. Well, in this case, at least the octet seems to be working. Yes. When electron is transferred, chlorine is able to take the electron of sodium because it's far more electronegative. The atoms, they do not transmute. What is transmutation? Have you heard the term transmutation?
Yes, I think change into
Another element.
another element, yes.
Exactly. Exactly. Um, I had a friend who bought herself a ring, and the guy trying to sell the ring was like, "Yeah, but you may get a better price here, there, and everywhere." And she was like, "Until people invent transmutation, I think gold is still gonna be gold." And I'm like, "Wow, that's a solid one. That's a solid one right there." The same thing occurs here. The electron structure doesn't change the chemical characteristics, the identity. What could change the identity if something happens in the nucleus? But it doesn't. Something in the case of magnesium oxide, two magnesiums, they give off two electrons, and obviously it's going to turn into white powder. Um, I used to do this experiment with a bit of magnesium. I would light it on fire, and it would produce a blinding flame. It's like a flashbang from Counter-Strike. I'm not sure if you're familiar with Counter-Strike. Usually boys
Uh,
play online
yes.
games. Oh, you know Counter-Strike. Oh my
Yeah, the
God. You
guys
are
from my friends. I have a lot of guy friends in our friend group, so yeah, I know most of those games because they keep playing something.
good. It's a social event. When I used to be a young man, my parents thought, oh, it's these boys not doing anything. No, 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 no. I have people from Iran and Israel being best friends through Counter-Strike. They're shooting each other, not in war, but online. And they wrote their thesis and they wrote a paper together about the benefits of online gaming and how this dissipated online aggression builds teams and builds lifelong friendships.
Yeah.
Mm. It's an extension of the human condition.
Yeah, I used to during COVID I used to play some video games as well and I made a friend and we're still friends like to this day.
Exactly, exactly, because you can be yourself online. You
Yeah.
don't have to pretend. And you can easily become best. I have a lot of friends from the United States because of it. I'm part of a I'm part of a veteran club, Vietnam War veterans, and we became friends. Usually Saturday night we have a beer together and we tell
Oh.
stories. Yeah, but online.
Oh.
Some of them came to Hungary. We met up and incredible people.
Uh-huh.
Their friends are just surprised. How did you guys become friends? Europeans, Hungarians, that's such a strange category. Or my friends who have been to the United States, they couldn't produce one single American friend, even over 10 years or even more. I mean, they had acquaintances and whatnot, but not friends they would talk to on a weekly or on a daily basis. And yeah, social media does keep you social. It's not just about, following your messiah, because a lot of people follow politicians and religiously support or hate them. I think in a perfect world, they shouldn't know who politicians are. In Switzerland, you don't know who your politician is. Why? They're doing a good job and they're not omnipotent. They don't have much power. They have local governmental power, but there's checks and balances. So I think that's the ideal. I'm not saying Switzerland's perfect, but it will always work because
Mhm.
different mentality and different morals. Yeah. Remain social with your friends and keep these contacts because
Yeah.
uh, people need this. And if you feel like messaging someone, but I don't want to be a burden, I don't want to bother them, do it anyways. Maybe they'll just won't react, but oftentimes it brings them back into life because A lot of people feel extremely lonely nowadays, what I've noticed, and I keep messaging them, especially people who I know are more vulnerable, in order to make sure that they're all right. And I think this is a toxic trait because I'm not responsible for everybody, obviously, but I want to make sure that everyone's all right. Yeah. 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 Magnesium oxide is a white powder. And even if I submerge it into carbon dioxide, the burning magnesium rod or the burning magnesium filament, it's going to be filament, it will still carry on burning, but it will produce coal. It will produce a dark soot or lumps of coal,
Mhm.
interestingly enough. So magnesium is a powerful incendiary device as well. So yeah, magnesium and methanol can burn everything down, in my humble opinion. Um, so one has to keep them on the lock and key and use them responsibly. Thank God not too many people know about this. And also, magnesium is essential, but it has to be absorbable. I can take magnesium oxide in the form of milk and magnesia and still not get it absorbed because the solubility of oxide and hydroxide is limited. My stomach acid, if it reacts with it, then obviously some of it might become absorbable, but excessive amounts of magnesium, as we talked about it previously, can upset the gastrointestinal tract and cause diarrhea. It's really odd how many things can ruin your GI tract. It's just incredible. We have to balance charge. That's how we balance formulas. Oftentimes, my kids would ask me, why is it MgO? Why isn't it Mg2O2? Well, you need the smallest proportions, yes? And this has also happened at McDaniel College. You'd be surprised, but a lot of Middle Eastern schools don't teach enough science. Heck, even
Yeah.
British schools are not going to teach enough science pretty soon because chemists are remarkable at not holding their own side and not proving it to buzzword-friendly, half-educated folk that you actually need a proper emphasis on science, not for fun, but to make it understandable, to build it up step by step. You know, I was at all, for example, a lot of cardinals don't understand Latin, and they're Catholic cardinals. And I was like, what the hell happened to you guys? But this is oftentimes a thing for chemists as well. I mean, we take a lot of things for granted instead of having the time and the opportunity to research it properly. Why is this? Why is that? Because then you're able to build up everything through reasoning. In the case of sodium chloride, easy. Magnesium chloride, you need one magnesium and two chlorines in order to even out charges, and that is what makes the compound in the end. You have to check the sum in the end. If it's zero, perfect, you got yourself a compound. This doesn't say anything about crystalline structure. This doesn't say anything about structure at all. The more common elements, the more common charges, these are going to be the most important ones from a physiological perspective and in most calculations. Iron can have a valence of 2 and a valence of 3 because of the d orbitals. Copper 1, copper 2 is also possible, but we'll talk about that a tad bit later. Sodium chloride, obviously, in its 3D shape, can it have this kind of crystalline structure? No, because the charges would never even out. So it's gonna be hexacoordinated, meaning one sodium's gonna have six chlorines around itself, and that is the crystalline structure it will form. Rock salt has cubic crystalline structure. Fluoride has a completely different
What do you
uh,
mean by
uh,
rock
uh,
salt?
rock
Oh,
salt,
the
table
MgO.
salt, sodium
Mhm.
chloride, it is the same thing. And in this case, this should be an no, that should actually be yeah, yeah. And obviously, when they become hydrated, the hydrogens from water turn towards the chloride, and the oxygen from water turns towards the sodium. But you're also going to have H3O pluses and others which are obviously going to turn towards the negatively charged the particles. But when water dissolves salt, it will hydrate these ions. Hydration is a special kind of solvation. Solvation
Yes.
means that the solvent's gonna cover basically the solute. This is how salt draws water, and salt is essential. Salt is what makes us human, virtually. It sounds strange, but it is true. And we managed to domesticate a lot of animals by having salt. Yeah, you'd be surprised. Wild animals started following us around because we had salt, and they were lacking salt, severely lacking salt. Um, my family has their family name because of salt. We would transport salt from Transylvania to the plains of Pannonia, and we would transport wheat and other valuable things back to Transylvania.
What do you mean
And
your surname? Like,
Kocsis, it means carter. We would have
yeah.
carts and just,
Oh, okay.
yeah, we've been doing it for 900 years, if not more. Yeah, I'm the fifth generation who doesn't. Yeah, it's weird, isn't it? Yeah, yeah, these names come from a reason. Yeah. But yeah, we would also have Schorsch, which means salty. They would have salt, and salt was essential in preserving food, and also it's necessary for life itself. Back in the day, in Roman times, it used to be valuable because of its rarity, and we could mine salt from the salt mines in Transylvania, which exist to this day. You've probably heard of the catastrophe at Porroid. It's okay. They opened the Ergibet mine, and it's still producing salt. Salt around the world varies from region to region. It is NaCl, but it may have a different impurity profile. For example, salt from special places in Iran is under such pressure that it turns blue. It's one of the rarest kind of salt on planet Earth. I have more than 25 kinds of salt at home because I love salt and
What do
I
you mean
love
you have different kind? You like for cooking or for baths?
uh, I have them as a collection, but some of them I do use for cooking. I mean, NaCl's NaCl, that's true, but how you bring it to the meal, well, that's a whole different story. For example, scaly salt, like kosher salt, is good for steaks. So is Muldoon salt. Now, if you have Muldoon salt, that is a scaly salt, you can smoke it. Why not add a twist to it? Yes, you can make this into an art form. Or if you have a harder rock salt, but you don't want to add so much salt to your pogacha because your dad has high blood pressure, you're going to use coarse salt that doesn't dissolve in the dough itself, but it forms these tiny salt pockets, so you can use a quarter of the salt amount and still leave everyone satisfied flavor-wise. Yeah, there's a lot of science going into this, isn't it?
Yeah.
And it doesn't raise his blood pressure dramatically, by the way. He ended up in the hospital when I made lasagna. He ate half a tray of lasagna, God bless him. It turns out his sodium levels were so freakishly high that they thought he was going to die. The
Oh.
next day he was all right. He peed it out. The doctors haven't seen anything like it ever since. But yeah, he made the Hall of Fame. Yeah, I told you that when he had to have a CT done, I had to take my dad to the zoo because he wouldn't fit in a human machine.
Oh my God.
We couldn't stop laughing
That's
about it.
possible.
Yes, yes, yes. If you're beyond 160 kilograms, it is possible, unfortunately.
And they actually do that, that they let people go in.
Yeah, sure, sure, sure. You pay for it, it's done. Or you ask nicely. In the Balkans, oftentimes asking nicely works. But if you pay a bit, it helps even more.
Uh-huh.
Yeah. No, people are nice, actually. I cannot say anything bad about, I mean, Romanian Orthodox Christians who mean that they're Romanian Orthodox Christians are one of the best people in existence. That's what I can say about them. I'm not saying they're always the cleanest, the most well educated, but they mean good. And they're trying to do good. And that's what counts. Yeah. So, yeah. Yeah. I think they went out of their way to do their best, and yeah, that's okay. I mean, don't get me wrong. He does have to take several kinds of medication, and I'm trying to get him to lose weight, not weight, fat. But yeah, the only person I've met who could save their parents is your dad, no one else. So hats off to him. In our case, it's far more difficult, or I don't know. We just haven't found the way yet, but we're going there. Uh, Yeah, but that's a feature on its own when you're able to break bad habits and turn everything towards good. I'd be proud to have a son like that. I mean, I'm proud of my son, don't get me wrong, but yeah, that's pretty awesome. That's pretty awesome. Now, in its ionic solid state, it's far more stable. Why does still salt dissolve in water? 'Cause why?
Why does
Full of
salt dissolve in water?
yeah, because thermodynamically it's unfavored. Thermodynamically, it could just say, screw you, I'm comfortable like this.
Mm,
It has to do with kinetics, obviously. It has to do with
mhm.
order.
Something
Thermodynamics
about
says order, yes? But nature,
yeah, we learned this at the I'm trying to remember.
the term entropy?
And I think so.
Yes, that's
Yeah.
right. That's right. Salt prefers disorder. So it will take energy from its surroundings and say, hey, I'm free in water. I can move my salty little butt around. True. Spot on. Charge and size control lattice strength. Yep. I'm
Yes.
small. I have a lot of charge. I'm strong. I'm big. I can't really hold on to much. I can probably melt in a spoon. Yeah. So it's going to be weaker attraction if we're further apart, stronger attraction if we're closer. Pretty obvious once you think about it, right? Ionic compounds are brittle. Have you ever made pesto?
Yeah, of course.
Well, I love making it in with a mortar and a pestle. It's more
Hmm.
personal and it's going to look more rustic and it's going to have a different flavor profile. In a blender, it may have bitter notes unless you add water to it or ice to it, but ice dilutes the flavor. And in a mortar and a pestle, well, the little guy is able to have fun, and you add large chunks of table salt, so it mashes up all the leaves. You just add it to pasta, turns out perfect, yeah, because it's a brittle crystal, and you can break it in a pestle with a mortar and a pestle. Are you able to hear me?
Yes.
Oh, we had a power drop. That's why I'm asking, because if the Wi-Fi went offline, then I have backup. As I said, I trust both governments, so I have backup. Because when people ask me about political questions, I just go with this. Look, this is the way I trust. So, yeah. I mean, in my colleagues and in God, I trust. Ideologues, keep your hands where I can see them. Molten salt conducts electricity because charges can move, and also salt water conducts electricity as well. Obviously, this solution is going to be very important. And of course, certain ions are essential for our normal well-being. And this is why we drink water. We can't drink distilled water. We have to drink water full of electrolytes. Yes, water full of calcium and magnesium might not be good for bathing,
Why
but
is it, I'm sorry, why is it not good to drink distilled water? Like it was, we can drink it, right? Or is it?
we can. It's not just it's just not healthy because it will draw electrolytes from our body.
Okay.
Think about it. If the concentration outside the semi-permeable membrane is low, well, it's going to suck out all the electrolytes from the cells. Yes, and
Mhm.
the water will be sucked inside the cells because it has higher turgidity on the inside. So the cells are going to swell up and they might even explode if we're not lucky. Um,
Hmm.
Hemolysis is oftentimes achieved by adding blood droplets to distilled water. So so red blood cells explode, and you're able to measure the amounts of hemoglobin inside. That's why it's not a good idea to drink distilled water. I have had colleagues who were doing cleansing and they used to drink a liter of distilled water a day. And I'm like, son, you're gonna get dehydrated. How am I getting dehydrated? I'm drinking water. Yeah,
Mhm.
man, but thought draws water. Where there's no salt, that's where the water's going to be.
Uh-huh.
And they got hospitalized with severe dehydration afterwards.
Ugh.
Yeah, there were these fat diets. They were trying to lose weight. They did lose weight, water weight.
Mm-hmm.
It's like having diarrhea. Yeah.
Mm-hmm.
Does it help you lose weight? Yes. Is it helpful? No. No.
Mm-hmm.
It actually it's very bad. I mean, if I want to lose weight, I can have one of my legs amputated. Am I going to lose a lot of weight? Yes. Am I going to be more fit? No. Am I going to lose fat? Definitely not. So one has to think about it. Do we want to lose weight? No. We want to increase our muscle mass and reduce our body fat. That's the bottom line. And that requires work. That requires effort.
Yeah.
Protein, fiber, lifting heavy, and running. That's it. It's not difficult. Sodium and potassium equilibrium takes up a lot of ATP because we need equilibrium. Yes. A lot of medical salts are used in rehydration therapy. There's also oral rehydration solutions, ORS solutions that help us maintain ourselves. Potassium, very important intracellular cation. A great source, potatoes, milk, bananas. Oftentimes all of them are good. Do you need sodium? Definitely. Do you need more sodium in the summer? Yes. Oftentimes you might be dehydrated because you might be experiencing hyponatremia, low concentration of sodium in blood. There's a kind of yogurt or kind of a yogurt-like drink called ayran. Iran is salty, and oftentimes in the Middle East, it's drank after a meal. It makes you a bit more thirsty, so you're able to drink more water, and it rehydrates you to having electrolytes because iron is not just going to be sodium; it's going to be calcium, magnesium, potassium, every good thing that comes from milk with the added proteins.
Mm-hmm.
So if you like it, try it. A lot of people don't like it, especially Hungarians from Budapest. A lot of them are like, no. The younger generation likes it. People of Armenian ancestry like it. People of Turkish ancestry like it. Iranians, they go crazy for the carbonated version that they take. It's called duk, and they drink it with mint because Iranians they always pimp up things. You know, you have something basic, and then they add saffron and mint to it, and all of a sudden it's like the Arabian Nights. And they're not Arabs. Don't get me wrong. It's just pimped up. IV in saline solution keeps you hydrated, and it needs to be isotonic with your insides. So it doesn't take away water, it doesn't push water into the organs, it just keeps things at equilibrium. Calcium is also essential, and so is magnesium. Strontium and other group 2 elements can take the place of calcium and magnesium. That's why they can be rather dangerous. In the case of covalent bonding, sharing, scaring, no one can take anyone else's electrons. In this case, even the little dots are fairly correct. Sometimes it slips my attention, and only when I start presenting do I still notice uh, some mistakes may remain, but oftentimes my students are going to be the first to notice. And usually I'm very proud of these kids because that means, first of all, paying attention to small details, second of all, being really smart. So, yeah, the two are going to be absolutely paramount for being a good medical doctor. Duets and octets make sense here, of course, and these are homoatomic covalent bonds, so the electrons belong to both participants the same way because their relative electronegativity is the same. Now, obviously, when electronegativity moves towards one of them, the electrons will be drawn in that direction, so it will be a polar covalent bond. You can share more pairs of electrons besides one, This is especially true in the case of carbon dioxide, and obviously an octet is going to be achieved, and double bonds are needed because there's going to be a sigma bond, and around it a pi bond is going to form. Yeah, do be careful not to add too many electrons by mistake. This is oftentimes a reoccurring mistake in regular students, and also AI may fail at this because it doesn't understand the octet rule. So when we share the electrons, we do not include them in the Lewis structure. That is the bottom line. These are the very common mistakes that may occur. In the case of triple bonds, again, 6 electrons are shared. How many are shared here? Too many.
Mhm.
Yes, we have to be very mindful of that.
Yes.
Oftentimes I put out a lot of dots and then I'm like, let's delete those. It's easy because I'm usually using a board, yeah. But in the exam, it's going to be multiple choice questions, so you'll be able to select the correct one. Single, double, triple bond, shortest, shorter, longest. The longest is the weakest one because the closer the nuclei are, the stronger the bond. Just like in every other case. It makes sense. Tendencies are pretty much understandable. What's wrong with chlorine in this case? Chlorine 2. We have
Mm,
we
there's
have too much of the good thing, right?
mhm.
That is just very good. In
Yes.
this case, obviously, that delta minus means that the electrons are drawn more towards the chlorine because of the great difference in electronegativity. In this case, again, too much of the good thing. Yes,
Why did you cross out the bottom two ones? Bottom two? Why not
because
the?
it's gonna be one and one. Yeah,
So it can be you can also cross out like one of the from one from the bottom.
yeah. Main thing is just the bonding pair.
Okay,
Yes,
okay.
that's the thing. Ja, vi hör less igen. Jo, Vanfian. There's gonna be rain apparently. That's amazing. Yeah. The boys here, the Navy, they blew up a few pieces of rock, and basically the reactor is running. They actually did something useful. So it appears that we are suffering due to incompetent governance here in the Balkans, and yeah, we don't really need that much of a political leadership. It would be really funny to write a paper on that with evidence supporting it. Also, chlorine is going to have an extra electron. Water, perfect. Chlorine here, is it good? Is it correct? Chlorine 2, non-polar covalent?
Chlorine two.
Hmm.
Yes.
Yay, perfect. Partial charges. Yes, carbon monoxide. Now, carbon monoxide's kind of a bitch. It's not a double bond. It's kind of a coordinate bond. Yes,
Mhm.
basically, oxygen pushes an electron pair towards carbon. That's why carbon monoxide is so severely toxic. It's a silent assassin. My dad almost died of carbon monoxide poisoning. He used to have a big black dog, and my family's creative. They called him Blackie. And the dog used to drink beer with dad. I don't think if one can be more Balkan. I asked him, Dad, are we gypsies? He said, No, we're not, but here's your grandfather's violin. And I'm like, that's kind of sus, you know? Then I asked him, was he able to read music? Oh no, he learned to read music at the age of 52. How did he play? Well, after hearing, dude, you're not making us less gypsy, you know that. He said, We're not gypsies. There's nothing wrong with being a gypsy. It's okay. It's just really funny. So, funny thing is, uh, we were talking on Facebook because we use Facebook because older people use Facebook, and all of a
Uh-huh.
sudden he became really slow, and I'm like, Did you light a fire? He said, yes. When was the last time you had a chimney sweep? We don't have a chimney sweep that often in Romania. I'm like, leave the house now, because you're getting poisoned by carbon monoxide. And he had to drag the dog out because the dog was already feeling ill. They survived. They hired a chimney sweep, and now everything's all right. In Hungary, each year you have to let into your home a chimney sweep just to measure carbon monoxide levels if you have any kind of private heat system. I think that's for the better. I think that's
Okay.
for the better because carbon monoxide can form a stable compound with iron, unfortunately.
Mm-hmm.
Now, oxygen 2 minus tends to be negative. Chlorine minus, they exist in this octet form because they love pulling electrons towards themselves because of their high electronegativity. And on the Pauling scale, obviously, oxygen 2 minus would have this electronegativity because oftentimes it can be even more powerful. And polar covalent bonds exist because of this. Now, compounds are not necessarily polar if the pulling effect evens things out. Molecular polarity depends on arrangement. If there's an electron rich one side, that means it's polar. But if it's electron rich throughout, well, it's non-polar like carbon dioxide, even though the bond itself is polar.
Mm-hmm.
We count, we connect, we complete, and we check. That's the playbook.
Mm-hmm.
And oh my God, there's a storm brewing. Ah, I promised to send you rain as well, just to freshen up, because oh,
It's 36 degrees here and sunny.
and there's gonna be colder weather dropping soon, and I think you're feeling the
It's
effects
supposed
of
to
that.
drop tomorrow, according
Yeah,
to
yeah, yeah.
weather.
You're feeling the effects. You're feeling the effects. I have
Yeah.
this wonderful ability as well. When the weather's about to change and there's electrical activity going on several kilometers away, I have a headache. I know what it's like. Then I overdose on caffeine because, oh my God, my internet connection is unstable. Can you hear me?
Yes, I can.
Okay, so sorry. In the case of a coordinate covalent bond, obviously, donor-acceptor type bond, the nitrogen donates an electron pair to that hydrogen, and obviously it's an 8 electron system. You can select the skeletal arrangement as well. Obviously, this doesn't always mean the absolute molecular structure. You connect atoms with a single bond. Then, if another bond comes in, then in another bond, and then you reach an octet. That way, this is correct so far. In the case of ammonia, again, fairly easy. Yeah, it wanted to put it on that, but we don't need another pair of electrons. Uh, either add a bond or add an electron pair, and there's going to be an electron pair on top. That's the correct representation of ammonia. Um, yes. Hydrogen always gets a duet, so again, fairly easy. This is correct again. I checked and double checked. Should be fairly all right. Yes. Multiple bonds. They're gonna take multiple valence electrons, and in the end, it's gonna end up in an octet. Main thing is octet and duet. That's the bottom line. And yes, these are correct representations of all of them. Same thing here. These are just going to be a couple of examples as well. Formal charges, electron accounting. So yes, that's about it about that. And I'm going to move on to shape in chemistry. There is a book by a man called Paul Mazei. Uh, yeah,
Mm-hmm.
he's Hungarian. In his CV, he has noted that he was born in Nagyvárad, Hungary. And I'm like, okay, this guy's got balls. I mean, it's true. It was Hungary back then, but it just seemed really fun to look at his CV. He's a theoretical chemist. Imagine a Hollywood actor from the 1940s
Hmm.
teaching you theoretical chemistry in impeccable English with a powerful Hungarian accent. I had a very difficult time understanding what he wanted to say because he learned English when he was 30 or even more. Értem, és he would use Hungarian words. And I loved the man, don't get me wrong. It was like, I had to sit to his lectures, and he invited me to earn my PhD in Canada, but I had to refuse because I already had an offer from Romania from my PhD supervisor, an amazing woman. She's also a diplomat. Yeah, an absolutely fantastic person. You can learn good habits and good management from. Oh,
Hmm.
you need proper mentors. That's always important. From a Lewis structure, you can discover electron domains. From there, you can easily predict molecular geometry, perhaps hybridization. Is it a sigma? Is it a pi bond? Is it polar or non-polar? What kind of medical consequences does it have? Because Paul G. Mesley's book was written in 2002, more than 20 years ago, but the tendencies were obvious. Yes? Shape defines function, and function allows control. So you're in control, or you're trying to be in control of a body that is sick. You're trying to remedy it. Are there any medications without side effects?
No.
No. That means if I manage to target what's wrong with it and I can make it specific, a lower dosage is going to mitigate side effects and it's far more likely to do what it was supposed to. Aspirin was a miracle in the 19th century. You had pain, you would take aspirin, pain goes away. It was fantastic. Nobody really cared about the side effects as much because pain is a powerful influence. But it's one of the most powerful teachers in the world as well. Don't put your hand on the stove. Why? It's going to burn. Yeah. A lot of people, well, not a lot of people, in some rare occasions, kids are unable to perceive pain. And they die early because of all the bad things that happen to them that are life threatening. Heck, even small children have to be monitored and watched so they don't produce micro fractures in their bones. Especially boys, but not just boys. I mean, you should have seen my sister. Absolute self-hazard. Yes, so that's a very important thing. Why is CO2 non-polar but H2O polar? Why do you think that is?
CO2 non-polar and H2O polar.
Mhm.
Something to do with carbon and hydrogen, maybe?
Not just that, not just what it's made up of, but how it's arranged.
Yes, arrangement of the structure.
Exactly, exactly. But it does have to do with carbon and hydrogen and oxygen. Very good, because carbon basically uses up all of its valence electrons. So the
Hmm.
center is not going to have that many electrons, but the sides are going to be full of electrons. In the case of water, is the reverse. All
Hmm.
the electrons are at the central atom. One side is a bit negative, the other side with hydrogens, not that abundant in electrons. The electrons are on vacation on the oxygen side, which gives it a dipole moment, which is why I'm able to heat my meals in a microwave. Yeah, microwaves. Yeah, those of us who lived in a dorm for a longer period of time or who are boys and lazy, they're going to be good at cooking everything in a microwave. We haven't had gas for an entire week, and obviously I bought another stove that is electric, but it took time for it to arrive, so I had to cook meals in a microwave. Well, thank God I lived in a dorm previously, because I've built cuisine around the microwave. It works. Not gourmet meals, obviously, not Gordon Ramsay style, but still good, edible. But yeah, you have to be able to adapt to new environments. And yeah, or you can just order food online, whatever. But back in the day, it wasn't available. Yeah, it's a recent addition. Since COVID, I think it became more popular and more common, right?
Hmm.
Ammonia is pyramidal, it's not planar because there's a lone pair, and that lone pair is big, and it's going to push all the other electrons away, which is going to change shape. Now, if I have a sigma bond and around it I have a double bond, I have an abundance of electrons. Yes?
Hmm.
And that abundance of electrons, well, it's going to change the shape. It's going to pull them closer together. It's going to form a stiff bond here. And these are going to look like little triangles in comparison to one another. However, anything that loves electrons is going to try and attack that double bond somehow. Why? Because it has yummy electrons, yes? An electrophile likes,
Elect
wants to catch electrons. Yeah.
electrodes. Yes.
Yeah, yeah. A nucleophile has electrons. It wants to catch something that doesn't have electrons. Yes. A pedophile is someone you talk to with a ball peen hammer. Yeah, I'm quite fluent in ball peen hammer. I actually own one. Yeah, there's a chapter of Hell's Angels in my district, and yeah, they're good people. They're good people. They go to orphanages. They cook paprikash krumpli. They're neurosurgeons, and I'm not even exaggerating, cardiologists. Usually they're fathers who dress up in leather and vroom vroom go around helping people. And if someone dares hurt the little ones or even look at them the wrong way, then they're deeply Christian, according to Matthew. It's, millstone, rope, you name it, they do it. They're good men. I look up to them because professionally they're great, and also they're charitable. They're good people. They
Oh,
might look a
so
little offensive, but they're good. They're full of tattoos. I mean, you look at them and you assume they did time. And when you look up from surgery, you see the same guy. Yeah, so yeah, they're like a Mars bar. Looks a bit rough on the outside, but sweet on the inside. Yes, it's rather remarkable in this regard. I don't know what pushed them in this direction, but they're doing the right thing, and bottom line, that is what matters. Yes, in the US, this is not the case. In Europe, somehow even the Hells Angels are good people. But they do have a ball peen hammer out of tradition. Yeah, it's a round and hammer. You can do woodworking with it, and you can bend metal with it as well. It's quite a useful tool.
mhm.
And yes, you can also talk to people who hurt kids with it. I haven't witnessed anything like that. I just heard rumors about it, obviously. Now, of course, shape is going to be defined by how many electrons we've got around. Well, that's just too many for water. How many electrons is oxygen going to have? Well, it's going to have just two of them, of the big ones, because it's
Mhm.
going to be full bonding and two lone pairs, which in summary, it's going to be eight. I wanted to make a big sigma, but my computer says, boss, I'm hot. Sure you are. And yes, the same concept applies to all of them. Now, if there's a single bond, it's one electron domain. Double bond, one triple bond, also one electron domain. So in the count of we count electron domains. We do not count bonds. That's the important part. A non-bound electron pair also counts as one domain. Yes, so because of this, the AX5 trigonal bipyramidal system exists. We have five ligands around the central atom. Does it exceed an octet? Yes. If
Mhm.
there's five ligands, that's going to be five binding pairs. However, in this case, it's going to be 90 degrees, and between these, it's going to be 120 degrees.
Mhm.
And between these, it's going to be 180 degrees. So, yeah, equatorial 120 apart, axial to equatorial 90, and axial to axial 180 degrees. And this is why phosphorus pentachloride exists in this predicament. A linear shape comes from basically two domains that push each other as far away as possible. A trigonal planar frame comes from basically three domains. It can be three bonds or two bonds and a non-bound pair. Yes?
Yes.
It makes perfect sense.
Mm-hmm.
It's not that difficult to imagine. And our usual reoccurring jokes, yes? Methane, ammonia, and water, as usual. Bond angles, do you have to memorize them? Uh, it's not bad if you know. If you know, you know. But anyways, it's good because when you have something similar, you're able to guess the good answer from multiple choice questions. In IB, it's not an issue. You have a data booklet. I think you can use it better than a Marine can use his rifle. And mind you, Marines are marksmen first and foremost. They're masters of the rifles. So yes, your data booklet, I think, is basically your second nature by this point. You already know where to look for things, right?
Yeah.
Tetrahedral, trigonal, pyramidal, and bent structure. We call it a bent structure. I go with V shaped because it is V shaped because it's water. Yeah.
Mhm.
Now, if you would just look at the bonds themselves, you could just say, "Oh, that's a trigonal structure. That's a linear structure." Ideally, if we wouldn't have the non-bound pairs, that would be true. But in this case, no, because of the extra non-bonding electron pair that pushes the other bonds closer together because it occupies a bigger volume in space.
Mm-hmm.
And virtually it's more negative. But this is why water remains polar. Water, when exposed to microwaves, it will move. And as it moves, as it rocks its little water butt, it will experience friction with other polar particles. Through friction, what is created?
Energy.
Energy, very good. And most of that energy gets converted
Mm,
into heat.
heat.
When
Yeah.
I don't want you to rub your hands together because it's 36 degrees there. But in the winter, if you rub your hands together, oh my God, the temperature can rise by 1.5 degrees Celsius.
Oh,
It's
okay.
measurable. It's measurable. I do this with my students all the time. Rub your hands together. Let's do a before and after. And it turns out, yes, it does produce powerful amount of friction. I have another phone. I call it the fat phone. The little one says Courier téléphone, and it has a thermal camera in it. It's a Chinese something, and it also has a microscope. So it's my scientific phone. And oftentimes I take photos of people's hands or eyes or whatever, and I put it on display. And they're at all. This is possible. Yes. And unfortunately, in high school, they don't approach chemistry from physics or physics from math. It's astounding. It's amazing. And it is why we're able to microwave our food. Yes. If I were to add something non-polar to the microwave, it probably wouldn't heat up as much. Or let's say the plate. The plate, if it's a glass plate, it doesn't really heat up much, does it?
Mm-hmm.
There's nothing that would be polar inside that could experience friction. And as you've seen, microwave doesn't really penetrate much. Yes? Just 2 centimeters. So if you're a microwave gourmet like myself, you're trying to heat your spaghetti and meatballs, yeah? Halftime through, you take out your meal, you stir it thoroughly, and put it back so it will uniformly get heated. Because the microwave oven uh, has these issues. Yes, it doesn't irradiate the whole thing the same way. That's the bottom line. VSEPR notation is going to be AX3, E meaning the electron pair, so it's going to become a polar molecule. Non-planar, the lone pair pushes the H atom into the pyramid. Water's going to be bent. We know why it's bent. Yes, and as you can see, AX5 is always a reoccurring thing, and so is PF5 because it exceeds the octet, and it's an interesting structure, and they go mad over it in exams, unfortunately. It took me a bit of a fight to get the structure to look all right, but it does. And axial and equatorial ligands occupy a certain part in space, and there's zero lone pairs on the central atom. Can there be a different structure? Yes, sulfur, for example, has six valence electrons. And this is again a bit of an exception. It's going to be a bipyramidal or an octahedral arrangement. Octahedron meaning eight sides. Yeah,
Hmm.
I think it comes from Greek, but I wouldn't bet on it. Xenon tetrafluoride. How? Why? Noble gases actually having compounds? What the hell gives? Yes, but you have to force them. I also have a story about this. I had an elderly guy teaching me scientific ethics and scientific authorship. He's my scientific granddad, if you will. His name is Professor Ionel Hajduk. He used to be the president of the Romanian Academy of Sciences, an incredible man. He wanted to make these compounds. They said, don't do it, it's a waste of money and time. And a mate of his did it in the US and he got the Nobel Prize in Chemistry. Mr. Hajduk can still nominate people for the Nobel Prize in Chemistry just between you and me. So, yeah, if someone does something remarkable, they will be nominated for prizes. But he's the one who told me, look, friend, uh, people who are nominated for prizes, they're the ones who get prizes, not
Hmm.
necessarily the ones who deserve it. And I'm like, dude. Sum up the Balkans in a better way for me. And this wasn't coming from bitterness at all. He knows the system and he's like that. I pretty much don't care much about such things because I know what we're doing is good and it's going to produce amazing new professionals in this world. And you go into a building and you know everyone, from the security guard to the guy in charge. Shit's going to get done. Yeah, you don't need a prize to achieve that. So it's the people that matter. How did they force xenon to react with fluorine? Well, low temperature, high pressure, but it did occur.
Hmm.
It did occur. Xenon exceeds its octet. Uh, and there's six electron domains around, four bonding pairs, two lone pairs. Virtually, it's sharing its electrons with fluorine. So, so yes, there's an electron pair above, below, two here, two there, and also two over there. And obviously the non-bonding electron pairs, they will try to keep as far away from xenon as possible. Not from xenon, from fluorine, because fluorine occupies the biggest space. So this is the most likely arrangement. Now, for how long does this exist? It's unstable at room temperature. All you can do is make an X-ray measurement, and that's about it. Under Earth conditions, it will not be stable. Why am I saying under Earth conditions? Well, elsewhere, I don't know what gravity is like,
Hmm.
what pressure is like, and what's temperature like. So most of the things we know about chemistry and day-to-day physics is just under Earth conditions.
Hmm.
Let's face it, that's like an incubator for science, isn't it? In the case of water is essential to all of us. Without it, there's no life, and there's no nuclear energy apparently. So we have to work wisely with what we got. Water is an absolutely necessary resource, as is salt, as is energy. And as a species, we should pretty much tone down the differences and work together towards a better future instead of just claiming it, actually doing it.
Hmm.
And there's a change. Oftentimes, I see people my age going against racism in words, but I do not see any deeds that brings people together. And they're going to have rude remarks towards one another as a playful act of playing a joke on these isms. And you need an intelligence of 120 IQ. Uh, oh my God. Can you still hear me? Hello? Hello? Can you hear me? Hello?
I think I can hear you now. Can you hear me?
Oh, yes, yes, yes. We had a slight power outage. I do apologize for it. Yeah, the electrical system is not as well developed in Romania, unfortunately. Uh, so yes, sometimes we have these issues. Uh, I think there was lightning, and as it occurred, it caused a small blackout, and then it came back online. I immediately shared my Wi-Fi with myself. So
Mhm.
yeah, I usually have phone internet, solar panels, so nothing can interfere with me teaching you kids. So yes. In the case of carbon dioxide, again, fairly obvious. I'm not telling you anything new with this. Water and carbon dioxide. Carbon dioxide is non-polar because the pull in all directions is the same. Water is basically, oh, why did you put two? There's just two electrons there. The third one, not necessary. Silly AI modeling. But anyways, bottom
Mhm.
line, underneath, you can see it actually understood. I was fighting so much with AI in order to create these slides, and it still left a few minor mistakes. Boron trifluoride and ammonia are oftentimes going to be compared. Now, this is something you're going to see both in IB and both in the entrance exam because teachers go mad over this. Again, three domains, four domains. The difference, you look at them and you immediately see the extra lone pair, right?
Mhm.
Now, what's the difference between monochloromethane and methane itself? Aha, there's an electron-rich domain right there.
Mhm.
hmm So it's going to turn out to be a tad bit more polar. What if I would change all four hydrogens to chlorine, carbon tetrachloride? Would that be slightly polar or will it turn non-polar?
Mhm.
I have a
Slightly
special
polar.
place in hell for that. All four ligands are the same around carbon. Will it have a
Mhm.
polarity or will it not? Think about carbon dioxide.
It will not.
It will not. Perfect. I used to mess with my Iranian kids at Duna College with this problem and they had a difficult time
Mhm.
getting it. But you did. This table also appears in your cheat sheet, yes, but not a
Yes.
biggie. As examples, you already know them, you already destroyed them virtually. And hybridization has to do with carbon specifically, and
Mhm.
these domains can change. Yes, SP is going to be linear. SP2 is going to be able to connect more. SP3 tetrahedral. Basically, domains get pushed together. This is a part of organic chemistry as well. But I intend on going over it in a nutshell. In the case of sp2 hybridization, one s orbital and two p orbitals merge together, hence creating this special. And the unhybridized orbital goes above the hybridized ones, hence a sigma and a pi bond are also going to be possible. You probably have heard the term sigma male,
Mhm.
right? It's being thrown around,
Yes.
sometimes jokingly, sometimes seriously. My high school kids asked me about what do I think about Sigma males. I said, if you need to add the Greek alphabet letter to your manhood, we have a problem. You could tie a carrot to it as well. Yeah, they smiled about it too. I mean, they're good kids, working out, studying, uh, being part of the gang. They don't push anyone away. Everyone's part of the gang. Everyone can be joked about. They will retaliate. They will retaliate, and that's good. That's good. I mean, they do say hurtful things to one another, but they don't mean it. It's kind of like a Italian family, yeah, between them, and there are various nationalities and whatnot, but they love each other dearly. If someone's sick, they're getting all the materials. They're asking teachers to make the class hybrid. Incredible people, and they're your age. So yeah, that's why I have such a positive image on young people. I mean, a lot of local kids whom came to the admittance exam and were admitted by me to university, they just got the gold medal in fencing. All of them girls. Yeah. Yeah, they're really good. They're really good at this. I'm proud of them. I mean, I have nothing to do with what they did, obviously, but I'm very proud that they managed that. Nitrile kind of looks like cyanide. Yeah, triple bond still counts as one domain. sp hybridization enables that. sp hybridization enables a second pi bond. Yes, and the second pi bond has a 90-degree angle with the first pi bond. Yes, in Z and in Y direction. This is a single double bond in the case of ethene or ethylene. Sweet smelling gas produced by bananas ripens fruit. Yeah, because it's a hormone as well. Acetylene, on the other hand, far more
Mhm.
linear, triple bond between them. It burns so wonderfully. It creates a mushroom cloud. Does it burn completely? No, it does produce a bit of soot, but I love it. A carbonyl group is going to have a double bond and two other domains, so it will be trigonal planar because, again, three domains around the central atom. In the case of benzene, it's going to turn a tad bit more complicated. It is still sp2 hybridization. However, there's something special going on here. All six carbons own the same number of electrons, and they share a single electron amongst all six of themselves. We're going to talk about this in greater detail in organic chemistry. I just wanted to introduce the concept first. And
Mhm.
basically, they do form an aromatic sextet. Sextet meaning six electrons being shared and belonging to each other the same way. Resonance hybridization may also occur. These resonance structures are virtually a representation of, an electron belonging to more atoms the same way. Delocalization
Mhm.
enforces the geometry. In amide bonds as well, we have this rigidity because of the delocalization of electrons between the oxygen and the nitrogen. And lone pairs and hybridization, there are a few exceptions about this as well. Amine sp3 is going to be pyramidal, but in amide sp2, there's going to be a delocalization resonance, which keeps the structure quite rigid. And of course, formal charges are going to support geometry as well, and it controls solubility and polarity likewise. And in drug recognition, that's the most important part. Shape is pharmacological info. That's why we have a protein data bank, and that is why we're so fond of theoretical chemistry. By the way, you can hear me, right? There was no interruption now.
Yes, again,
Oh,
again,
okay.
yes.
No, because we're having a power outage because it's raining. See, I was right to trust the government. I'm sorry, that was really bitter of me. Uh, these are very
It's
important.
okay.
Ammonia, nitrate group, phosphate group, sulfate, also tetrahedral in structure. Phosphorus pentachloride, sulfur hexachloride are very important as an exception. And yes, here are the most common exam traps in a nutshell. And of course, polarity. Can you tell
Uh-huh.
which is polar, which is not? It depends on the structure and if there are any lone pairs. The usual suspect, you already said it's non-polar. In this case, it is polar. Why? Because of the shape. One side more abundant in electrons, the other side less abundant in electrons. In this case, is it polar? Yes, because it's a band structure and there's an electron-rich domain. And in carbon dioxide, the electron-rich domain is missing. Pookie's missing. Oh, we gave shorts on the little guy, and he's like, the rest of my trousers are missing because he never wore shorts before. Yeah, it sounds strange. Yes. Here's a summary for hybridization. This is going to be a boom in organic chemistry and in chemistry as a whole. You're going to love this. Sigma and pi counting. How many of them are there? How many pi? 12 sigma in a delocalized pi electron system is equal to 3 pi bonds. Obviously, uh, benzene is really special in this regard. I don't know what Mr. Caculé was smoking, but he dreamt of monkeys holding each other's tails. And like, okay, I should probably not sniff glue like he did. And yes, this geometry table is going to help you wonderfully, but I think you have something similar in your IB exam sheet as well. What's I always call it a cheat sheet, but I think it's called a function table or something of the sort, right?
Mhm.
Okay. And you have a few solved problems just to help you with a couple of exceptions. So they
Uh-huh.
can't catch us with tougher questions with our knickers down, yeah? Where we're going to be able to tell. Ozone, ozone is second year chemistry. There's a problem, but it may appear in IB and in other places. So yes, it is a bent structure. Obviously, it's going to have a bond angle because of resonance structures. So O-O bonds are going to be equivalent. Central one's going to have an extra electron pair, hence the slight polarity. There's an atom dipole. And of course, urea is also an important school example as well. And yes, it's going to be a trigonal planar shape. And of course, certain anesthetics are going to have molecular motives that are going to contribute to their use as anesthetics. They change the shape slightly and reduce side effects and reduce the effects that are undesirable. And yeah, I mean, that's about it. I don't want to keep you for longer. I have this tendency of talking too much, so I don't want to keep you for too long. I'm going to